Divisibility rules. So let us see few rules according to your syllabus in this topic now. First one, divisibility by 2. So without doing normal or actual divisions, so using these rules we can say that number is exactly divisible by or not. Right? First one, divisibility by 2. As we discussed previous, a number is divisible by 2 if its last digit is even number. Already we discussed, no? Even digits are 0, 2, 4, 6, 8. Last digit must be 0, 2, 4, 6 or 8. So any number that is divisible by 2. Now let's take 1324. So this is divisible by 2. Exactly, because the units place is a even digit. And 16,978. So 8 is in units place. So last digit is either 0, 2, 4, 6 or 8. Then that is divisible by 2. Right? So all the even numbers are divisible by 2 as we discussed previous. Next, divisibility rule for 3. A number is divisible by 3 if the sum of its digits is divisible by 3. Sum of the digits is divisible by 3. It consider 4215, right? To check this number is divisible by 3 or not, sum of its digits 4 plus 2 plus 1 plus 5. You can add the digits. 4 plus 2 6 plus 1 7 plus 5 is 12. Now 12 is divisible by 3. 12 is divisible by 3. Same way this number is also divisible by 3. Now 12 is the number. 12 is exactly divisible by 3. So this 4215 also divisible by 3. Next, divisible by 4. For this rule is the number is divisible by 4 if the number represented by last two digits is divisible by 4. Last two digits. So let's take the example 1272, 19,316. These are divisible by 4 because 72 is last two digits. 72 is divisible by 4. 16 is divisible by 4. So even 19,316 also divisible by 4. For rule for 4 is last two digits is divisible by 4. And rule for 5. 5 is a number is divisible by 5 if its last digit is 0 or 5. Because if you see the 5 table, only 0 or 5 is in last digit, that is units place. So 13,715. So units place is 5. Right? 10,990. Units place is 0. Either 0 or 5 in last digit, that is units place. That number is divisible by 5. Right? Again, when it is divisible by 6. Rule for 6 is a number is divisible by 6 if it is divisible by 2 and 3. Both 2 and 3. And word is there. So its number must be divisible by 2 and 3 also, both. So let us take example. If I take 24. So according to the divisibility rule for 2 is units place must be 4. And according to 3, 2 plus 4 is equal to 6. 6 is divisible by 3. So 24 is divisible by 2 and 3. So 24 is divisible by 6 also. Both should be in this case, right? So if one is not acceptable also, you can't take this. Compulsory it should be divisible by 2 and 3, then that number is divisible by 6. Next, rule for 8. This is same like rule for 4, but in this case last to 3 digits. So last 3 digits are divisible by 8. Then the number is divisible by 8. Right? Let's take example 5408. To check this number is divisible by 8 or not, last 3 digits. 408 is exactly divisible by 8. Then you get the remainder 0 in this case. So remainder is 0. That means even 5408 also is exactly divisible by 8. Same way the last one, like 632432. So 432 is divisible by 8. So this number is also divisible by 8. Rule for 9 and rule for 3 is same, but in this case sum of the digits is divisible by 9. Sum of the digits is must be divisible by 9. Let us take one example. 7236. To check this number is divisible by 9 or not, 7 plus 2 plus 3 plus 6. 7 plus 2, 9 plus 9. So 18. 18 is exactly divisible by 9. So this 7236 also divisible by 9. So number is divisible by 9 only if the sum of the digits is divisible by 9. And rule for 10. 10 is simple, just the last digit is 0. The last digit or the digit in ones place must be 0. Any number 6340. So units place is 0. Okay, 199, any big number, you can keep 0 in the units place, that is divisible by 10. Next, see the rule for 11. In this case, so rule for 7 is not there, so that way we are not taking 7 in this. So divisible rule for 11 in the account syllabus. If the difference of the sum of alternative digits of a number is divisible by 11, then the entire number is divisible by 11. Let us say, take one example. 90,816. So sum of the digits in odd places and sum of the digits in even places. So you can take 9, 8, 6. 9 plus 8 plus 6 do addition. Again, other places. Odd number place and even number places. 0 plus 1. 9 plus 8 plus 6. Up to here is 23. 0 plus 1 is equals to 1. Now difference. You should do subtract this both. So 23 minus 1, 22. So the result is divisible by 11. That number is also divisible by 11. So if the difference of sum of alternative digits, alternate places, 1, 3, 5 places, again second and fourth places, you should add separately and subtract. The result, if it is divisible by 11, then that number is divisible by 11. Okay, this is for rule for 11. So let's take 1, 2, 7, 4, 4, 6. Check this number is divisible by 11 or not. So first, third, fifth place is addition. 1 plus 7 plus 4. This one minus other places. 2 plus 4 plus 6. 2 plus 4 plus 6. So is 8 plus 4. So 12 and this is 12. So 0. Either you get 0 or multiples of 11. That number is divisible by 11. Not only 0. 0, 11, 22, 33. Any number after doing subtraction if you get, then that number is divisible by 11. Right? These are the basic or important properties, rules for divisibilities. Now let us see the divisibility properties. Not only rules, let me explain the divisibility properties also now.